So we need to integrate tan power 8x secant power 4x. Now because the power of tan is high, not that high, but yes, 8 is a high power. So if somehow we have secant square x dx with this power of tan, because you know that the derivative of tan is secant square x, so we anyhow need secant square x dx if we want to substitute tan x as t. I can see that secant square x dx present here. If we just rewrite or rearrange this, you can write this as tan power 8x, no problem with this. Now secant power 4 can be written as secant square x times secant square x. So secant square x, and the other secant square x dx is what I was looking for. But this extra thing is there. I need to get rid of this, or anyhow convert it into something related to tan. So I know from my basic trigonometry formulas, secant square x is 1 plus tan square x. Fine. So this is integral tan power 8x. This is nothing but 1 plus tan squared x, and there we have secant square x dx. There we go. Now the stage is set to take the substitution forward and tan x as t. So as to get the derivative of tan x, you all know secant square x dx equals to dt. Fine. So I can rewrite this integral as t power 8 1 plus t square, and secant square x dx is nothing but dt. I can multiply this t power 8 inside, so I'll get t power 8 plus t power 10 dt. Now this is simple. If you remember the basic, the first video, I told you x power n integration, and that is x power n plus 1 divided by n plus 1. So here you go, t power 8 plus 1 is t power 9 divided by the same power. Here again t power 10 plus 1 is 11 divided by 11 plus a constant c. Now it's time to back substitute t because it was our assumption. So this is tan power 9 divided by 9 plus tan power 11x divided by 11 plus. So this is the final answer which all of us were looking for. So again, not that difficult. Only thing you have to keep in mind that if you have any function of tan, you need secant square x in picture. So I generated secant square x out of secant power 4. One extra secant square was there, which I can always write as 1 plus tan square x, and I move forward with the substitution tan x as t, and this was not at all difficult afterwards. So that's it for today. You can watch out more such similar problem also involving tan and secant in the playlist integration 2023.